let's do this. Journey with me as we face, overcome, and befriend the challenges ahead. We can because we are Mathematisin yan. I am Teacher Andrew, your soulmate. Allow me to guide you in learning the different concepts and skills in Mathematics 9. In the previous episode, we determined the nature of roots of a quadratic equation based on its discriminant. And we recorded our observations in the table of highlights. And since we should not bury the skills and concepts we have previously learned, we say, pass not debt. Let us solve for the roots of the following equations using the quadratic formula. Remember CS4? I gave this acronym for easy recall of the procedure we do to solve quadratic equations using the quadratic formula. Equation number 1, x squared minus 9x plus 4 equals 0. Let us determine the value of the coefficients a, b, and c. A is 1, b is negative 9, and c is 4. We now substitute the value of these coefficients in the quadratic formula. Next, we simplify. Then, we split the equation into 2. But since we cannot simplify further, the values of x are 9 plus square root of 65 all over 2 and 9 minus square root of 65 all over 2. Equation number 2, 8x squared minus 12x plus 1 equals 0. Let's do this. We identify the value of the coefficients. We substitute the value of a, b, and c in the formula. Then, we simplify. The highest perfect square factor of 112 is 16. Thus, we express 112 as the product of 16 and 7. We take out the principal square root of 16, which is 4, and retain 7 under the radical sign. 12, 4, and 16 are divisible by 4. So, we apply the concept of GCF to reduce the expression to its lowest term. We split the equation into 2, showing the unequal nature of the roots. We are supposed to solve for x as the last step. The values of x are 3 plus the square root of 7 all over 4 and 3 minus the square root of 7 all over 4. Now, let me show you again the two quadratic equations and their roots using a table. Our next task is to determine the sum and the product of the roots of each equation. Let's start with getting the sum of the roots. For equation number 1, we have 9 plus the square root of 65 all over 2 plus 9 minus the square root of 65 all over 2. Since the two have the same denominator, we just use this common denominator and then add the numerators by combining similar terms. So, upon computation, we have obtained that 9 is the sum of the roots. For equation number 2, we have 3 plus the square root of 7 all over 4 added to 3 minus the square root of 7 all over 4. Again, since the two have the same denominator, we just use this common denominator and then add the numerators by combining similar terms. And we always reduce the answer to its lowest term whenever possible. So upon computation, we have obtained that 3 over 2 is the sum of the roots. Let's record the results in the table, highlighting the sum part. Next, we get the product of the roots. For equation number 1, we have 9 plus the square root of 65 all over 2 multiplied by 9 minus the square root of 65 all over 2. We multiply the numerators and we also multiply the denominators. And in multiplying the numerators, we encounter a case of special products, which is the sum and difference of two numbers. So, we multiply the first terms and then the last terms. 9 times 9 is 81. Square root of 65 times itself is just 65. Recall that when you multiply a radical of index 2 by itself, the product is equal to the radicand. Hence, the product of the roots of the equation is 4. For equation number 2, we have 3 plus the square root of 7 all over 4 multiplied by 3 minus the square root of 7 all over 4. We multiply the numerators, we also multiply the denominators. And in multiplying the numerators, we encounter again a case of special products, which is the sum and difference of two numbers. So, we multiply the first terms and then we multiply the last terms. 3 times 3 is 9. Square root of 7 times itself is 7. Again, when you multiply a radical of index 2 by itself, the product is equal to the radicand. Hence, the product of the roots of the equation is 1 over 8. Let's record the results in the table, highlighting the product part. Now, let's relate the sum and product of the roots to the coefficients of the quadratic equation. Let's study this table. The sum of the roots could be related to the value of the coefficient b, but is not equal to the value of the coefficient b. We might be tricked to think that the sum of their roots is equal to the negative of the value of the coefficient b, because in the table, we can see that the sum of the roots of the first equation, which is 9, is equal to the negative of negative 9. But you see that this doesn't apply to the second instance, which is 3 over 2 is not equal to the negative of negative 12. We have to identify the rule that applies to all. Since the sum of the roots of the second equation is a fraction, this could suggest that two coefficients are involved and that one is divided by the other. Let's focus on 3 over 2. This is an improper fraction, which is in simplest form and is positive. Looking into the coefficients of the equation 8x squared minus 12x plus 1 equals 0, definitely the sum of its roots is not equal to a coefficient divided by c. Since dividing by c will yield an integer, whereas the sum of the roots of the equation is not an integer. It can neither be c divided by another coefficient, since c in the equation is 1. The sum is an improper fraction, not a proper fraction. But if we will pursue our assumption that two coefficients are involved, and definitely c is not one of them, then the sum of the roots involves the coefficients a and b. But is it a over b or b over a? Take note, the sum is an improper fraction. In the equation, the coefficient a is positive, while the coefficient b is negative. They are of opposite signs, which means that the quotient will be negative. However, the sum 3 over 2 is positive. So this implies that we should get the negative of the quotient of the two coefficients. So the question now is it negative of a over b or negative of b over a? Let's check. Negative of a over b equals the negative of 8 over negative 12, and it must be equal to 8 over 12, which is positive, and can be simplified as 2 over 3 or 2/3. And 2/3 is not equal to 3 over 2. Thus, it can't be the negative of a over b. Let's try negative of b over a. Negative of b over a is equal to the negative of negative 12 over 8. And it must be equal to 12 over 8, and can be simplified as 3 over 2. And yes, it is equal to the sum of the roots of the equation. Alright, so it appears that the sum of the roots of a quadratic equation is equal to the negative of b over a. Let's see if this applies to the first equation whose sum of roots is 9. Negative of b over a is equal to the negative of negative 9 over 1, which is equal to the negative of negative 9, which is equal to positive 9, and yes, equal to the indicated sum of the roots, which is 9. And so the rule applies. The sum of the roots of a quadratic equation is equal to negative of b over a. Another way to see how the coefficients of the quadratic equation are related to the sum of the roots of the equation is by using the quadratic formula. So we split the equation into two to show the expression equivalent to x sub 1 and x sub 2. They are almost the same, it's just that x sub 1 contains a plus sign after negative b, while x sub 2 contains a minus sign after negative b. So, what is x sub 1 plus x sub 2 equal to? Since they have the same denominator, we copy this common denominator and then add the numerators by combining similar terms. Then, we simplify further. So, we have obtained that the sum of their roots denoted by x sub 1 plus x sub 2 is indeed equal to the negative of b over a. How the coefficients of the quadratic equation are related to the product of the roots is also answerable by the quadratic formula. We split the equation into two to show the expression equivalent to x sub 1 and x sub 2. We multiply the numerators and then the denominators. To quickly get the product of the numerators, we treat it as a case of special products, since we are to multiply sum and difference of two numbers. Negative b times itself equals b squared. The square root of the expression b squared minus 4ac times itself is equal to b squared minus 4ac. Then we combine similar terms. Then we can simplify by applying GCF. Based on this computation, the product of the roots of a quadratic equation is equal to the expression c over a. Let's refer to the table again. We now check if this rule really applies to all. The value of c in the equation x squared minus 9x plus 4 equals 0 is 4, while a is 1. So c over a must be equal to 4 over 1, which is just equal to 4. And this result is equal to the product of the roots of the equation. It works on the first equation. Now, what about on the second one? The value of c in the equation 8x squared minus 12x plus 1 equals 0 is 1, while a is 8. So c over a must be equal to 1 over 8, which is equal to the fraction 1/8. And this result is equal to the product of the roots of the equation. So it also applies to the second equation. Hence, the product of the roots can easily be obtained by dividing the value of c by that of a. Let's keep our minds active by answering this set of exercises. Kindly ready your pen and paper. Here is Math the Moment. So, given the equation, we will identify the sum and the product of its roots. Kagamath, let's do this. Equation number 1, x squared minus 6x minus 27 equals 0. 15 seconds, go! And time is up. The sum is 6, while the product is negative 27. Equation number 2. X squared minus 25 equals 0. Find the sum and product of the roots in 15 seconds. Go! and freeze. Sum is 0 and the product is negative 25. Equation number 3 now. X squared minus 10x plus 25 equals 0. You have 15 seconds. Go! And time is up. Sum is 10, while the product is 25. Equation number 4. 2x squared minus 5x plus 3 equals 0. For another 15 seconds, go! And time is up. The sum is 5 over 2, while the product is 3 over 2. Now we have equation number 5. X squared plus 5x plus 4 equals 0. Another 15 seconds. Go! And 15 seconds is up. Sum is negative 5 and the product is positive 4. So, when a quadratic equation is written in the form ax squared plus bx plus c equals 0, we must remember that the sum of its roots is equal to the negative of b over a, while the product is equal to c over a. Now, if we divide each term in the equation of the form ax squared plus bx plus c equals 0 by a, we should get x squared plus b over a of x plus c over a equals 0. Notice the coefficient of x, which is b over a, is just the negative of b over a, the sum of the roots. On the other hand, the constant term c over a is equal to the product of the roots, which is also represented by the same expression. What am I trying to point out? Well, say we're given the sum and the product of the roots, we can write the corresponding quadratic equation. Let me give the first example. The sum of their roots is 8, their product is 12. Form the equation. We are guided by the form x squared minus the negative of b over a of x plus c over a equals 0 in writing the equation that corresponds to the given sum and product of roots. We substitute the value of the sum and of the product in the equation. Hence, we have x squared minus 8 of x plus 12 equals 0. Then by obtaining the negative of 8 as indicated, the final equation is x squared minus 8x plus 12 equals 0. Second example. The sum is 4 over 7. The product is negative 3 over 49. Substituting these values, the resulting equation would be x squared minus 4 over 7 of x plus negative 3 over 49 equals 0. By finalizing the signs of the terms, we write x squared minus 4 over 7 of x minus 3 over 49 equals 0. We may get rid of the fractional coefficients by multiplying the entire equation by the least common denominator or LCD of the fractions, which in this case is 49, because the LCM of 7 and 49 is 49. So, the equation in standard form with integer coefficients is 49x squared minus 28x minus 3 equals 0. Third example, the roots of the equation are 2 and 3. Here, we are not given the sum and the product of the roots, but the roots themselves. So what do? We just add and multiply them. The sum of their roots is 5. Their product is 6. So we're now ready to write the corresponding quadratic equation. And the equation whose roots are 2 and 3 is x squared minus 5x plus 6 equals 0. Last example, the roots of the equation are square root of 5 and the negative of square root of 5. So we have to add and multiply these roots. Then, we substitute the obtained sum and product of roots to form the equation. Then we finalize the signs. In this case, there shall be no middle term since its coefficient is the negative of 0, which is still 0. Multiplying by 0 means getting 0. Thus, the equation whose roots are square root of 5 and the negative of square root of 5 is x squared minus 5 equals 0. Of course, we don't proceed elsewhere unless we answer some exercises. Are you ready, Kagamath? So, ready your paper and pen and let's do this! We will form the equation given information about its roots. Item number 1. Sum is 2. Product is negative 8. 15 seconds. Go! And time is up. The answer is x squared minus 2x minus 8 equals 0. Item number 2. The roots are 7 and negative 2. Another 15 seconds. Go! Time is up. The answer is x squared minus 5x minus 14 equals 0. Item number 3. The product of the roots of the equation is 51. One of their roots is negative 17. For 30 seconds, go! Time is up. Dividing the indicated product by the given root, we can obtain the other root, which is negative 3. So the equation is x squared plus 20x plus 51 equals 0. Let's level it up. Here we go, super math. A rectangular garden has an area of 132 square meters and a perimeter of 46 meters. Question number 1. Expressed in meters and in terms of its width, what expression represents the length of the garden? For 15 seconds, go! And time is up. The answer is, the length is equal to 23 minus W. Question number 2. What equation would describe the area of the garden? Write the equation in terms of the width and in standard form. 30 seconds on my mark. Let's do this! Since we may omit the unit square meters on both sides of the equation, the answer is w squared minus 23w plus 132 equals 0. Question number 3. What are the roots of the equation formed in number 2, which is w squared minus 23w plus 132 equals 0? For 30 seconds, go! The answer is w sub 1 is 11, w sub 2 is 12. Question number 4. What is the sum of the roots of the equation? How is this related to the perimeter? For 15 seconds, go! Answer: 23, and it is equal to the total number of meters when the length and the width of the garden are combined. Question number 5. What is the product of the roots, and how is this related to the area of the garden? For another 15 seconds, go! Answer: 132. It is equal to the number of square meters contained by the garden, or simply the area of the garden. And that's it, Kagama. I hope today's episode has been very helpful. This is your Solvemate, Teacher Andrew. Before we go off air, let me share another motto I hold on to as a mathematics teacher and learner at the same time. Do not hate what you do not know. See you again next time as we face, overcome, and befriend the challenges ahead. We can because we are Mathematis yan.